All right, here we go. Let's do Module 1, Lesson 4. We're going to learn about another method, actually two other methods, of dividing polynomials. One method we'll learn about week-long division. We will also learn about synthetic division, which is not covered in Eureka, but is a really, really useful tool that I feel needs to be something you can use when you need to. It'll save you a lot of time. But anyhow, let's just go along with this lesson right now. It's asking us to use the reverse tabular method to determine the quotient. Of course, we already know how many rows and columns this would be, but it's determined by, remember, the degree of our denominator is 1. So the number of rows that we're going to have is 1 plus 1. So you see that there are 2 rows there. The number of columns is going to be determined by the degree of our numerator minus the degree of our denominator plus 1. So what is that? That's 3, since we have that x to the third power, minus 1 plus 1, so 3. So that's how it was determined that we needed to have a 3 by 2 table here. Let's fill this thing in. We have 2x cubed here. We're going to put our 11x squared here. 7x will go here. And the 10 here. So that's where we put our numerator, or our dividend, our divisor, or our denominator. We'll go there, right? And what we're trying to figure out is what would we multiply times x plus 5 to get 2x cubed plus 11x squared plus 7x plus 10, right? We need to fill in the top number. So let's do that. So first thing, 2x cubed is going to go there. That's always your giveaway. Next, I need to figure out what do I multiply times x to get 2x cubed? That's going to be 2x squared. 2x squared times 5 is 10x squared. What did I multiply? Sorry, what did I add to 10x squared to get 11x? Well, it's going to be x squared. And then what did I have to multiply times x to get x squared? That's x. X times 5 is 5x. This is a 2x. 2 and 10. I'm just going through that quickly because it's something that we've already really focused on. All right, so what does that mean? That means that our quotient is 2x squared plus x plus 2, right? It's always a number on the top. All right, so from 1, we're going to use our work to write that in factor form, and then we're going to multiply it. All right. Sorry, I keep looking up because, I need to actually know what my quotient is, because what they're asking is they want me to write this in this way. They want us to say that, hey, if we were to factor this, we would be able to factor out an x plus 5 and a 2x squared plus x plus 2, right? We're saying that these things are equivalent here. All right, so we were able to divide to actually find the factor form of the polynomial 2x cubed plus 11x squared plus 7x plus 10. Fantastic. Let's not actually multiply that thing out using the tabular method. Let's continue on and just get to the meat of lesson 4. And this is the meat of it right here. Polynomial long division. Alright? So the first thing I'm going to do is actually divide 1,573 by 13. Remember how we set that up? We're going to put the number that's being divided, the dividend, underneath our division symbol and our divisor. Goes on the outside. And you remember how we did this? It's been a long time probably since you've done some long division. But we're going to say, hey, 13 goes into 15 one time. I got a 13 down here, right? Because 1 times 13 is 13. And then I go ahead and subtract, right? 15 minus 13 is 2. And I drop down the 7. All right? How many times does 13 go into 27? It goes in there twice, right? And then I go 2 times 13 is 26. And I subtract, and I get a 1 there. I drop down the 3. And how many times does 13 go into 13? 1 time. Right? 1 times 13 is 13, so there is a 0 remainder. So, 1,573 divided by 13 is exactly 121. Well, we can use a similar idea in order to do this, right? It turns out that the x is representing the tens place. X cubed is representing our thousands place. X squared, hundreds. X, again, tens. And then we have our x to the 0 power is our ones place. Let's go ahead and multiply this thing out using long division. Alright, so I'm going to actually rewrite the problem just right over here, because I'm going to run out of room if I do not. So I'm going to write x plus 3. And then we're going to divide that into x cubed plus 5x squared plus 7x plus 3. Here we go. Alright. So when I'm doing this, I'm looking at my variable quantity. So I see that x cubed there, and I see the x. I need to think to myself, what do I multiply x by to get x cubed? Well, that's going to be x squared, right? And x squared times x. So now what I'm going to do, just the same way in the division, I multiply to get a number underneath. I'm actually going to multiply to get the number, a polynomial expression below that x cubed. And it turns out it's also going to be below the 5x squared. The way that I'm going to do that is I'm going to distribute this x squared. So x squared times x will give me this x to the 3rd power. And then x squared times 3 gives me a 3x squared. Okay? And now, I am actually going to be subtracting. So, another way to look at subtraction is that you're changing the signs of these polynomial expressions and adding. And I have something that I like to do to help me keep track of that. So this one was positive. I'm going to make it negative. That one's positive. I'm going to make it negative. And now I'm going to add. So I am subtracting these two. But instead of actually subtracting, I distribute a negative sign and then add. It just helps me personally to make less mistakes if I do it that way. And then I like to circle it so that I know that I changed the sign. It helps me, it just really helps me to stay organized and make a lot less mistakes. So now I'm just going to do 5x squared plus negative 3x squared. That is going to give me 2x squared. The x cubes canceled, right? Because x cubed plus negative x cubed is 0. Now I'm going to drop this down, just like I did when I did the long division problem over there. Same thing. Okay? Now I need to go through the same process, just like I did with the long division, right? If we look at that, when we got to that, to the point over here in our numerical long division problem, where we had subtracted 13 from 15, and we had 27, right? We had this 27 right here. What did we do? We said, how many times does 13 go into 27? It goes in 2 times. We're going to do the same thing here. How many times does x go into, or what is 2x squared divided by x? Another way to look at that, right? You could look at that in terms of multiplication. I could say, hey, what do I multiply x by to get 2x squared? And the answer is 2x, right? And we're going to multiply that back out. Again, we're going to distribute the 2x just the way we distributed the x squared. So 2x times x is 2x squared. And 2x times 3 is going to give me 6x, right? And they're both positive. Again, I'm going to subtract, but I prefer to look at that as changing the signs and adding. So the 2x squared minus the 2x squared is 0. And 7x minus 6x is x. Next thing I'm going to do, I'm going to drop down the 3. Oh, fantastic. That's very nice. So, what do I need to multiply x by to get x? Well, that must be 1. And then when I multiply that back out, distribute the 1. 1 times x is x. 1 times 3 is 3. We get 0. That means that we have no remainder. We have a 0 remainder. So then we can say that this is equivalent to x squared plus 2x plus 1. And then we're done. Let's do it again. We're going to do this lots and lots of times. And also get to show you some synthetic division as well as we get into this. And we'll learn exactly when you would want to use each one. So let's go ahead and use long division to find this quotient. So right, we're saying we want to know what is 2x cubed minus 4x squared plus 2 divided by 2x minus 2. There we go. Ford just had a little moment. Here we go. 2x cubed divided by 2x, or we could say, what do we multiply 2x by to get 2x cubed, is going to be just x squared, right? And then when I distribute the x squared times 2x gives me that 2x cubed, and that's awesome, right? You want those first terms to match so that when I subtract, they go away. X squared times negative 2x squared is going to be, of course, negative 2x squared. I'm going to go ahead and subtract, or change the signs and add. The 2x cubes, of course, go away. That's what we wanted. Negative 4x plus 2x will be negative 4x squared plus 2x squared will be negative 2x squared. I'm going to drop down the 2. There we go. And then I need to think to myself, what is negative 2x squared divided by 2x? Or, what do I multiply 2x by to get negative 2x squared? Well, that's going to be negative x, right? And when I distribute that, I wind up with a negative 2x squared, right? Negative x times 2x is negative 2x squared. Negative x times 2 times negative 2 is going to give me negative Sorry, I might be positive 2x. And something weird just happened, right? What happened? They're not lining up. And this is the reason for that. It turns out that just the same as we needed to do when we were doing our reverse tabular method, we got to have placeholders. So what's missing is the placeholder for my x value in there. And the same is true for your divisor, right? If I have x squared minus 2 as my divisor, I'm going to have to put in a placeholder for that x value. So there would be x squared plus 0x minus 2. It works much better when you put the placeholders in there. So I'm going to just go ahead and go through. We've already got this part done, right? So we're going to fill in these values. We're going to wind up with negative 2x squared. And now this works out, because when I drop this down, I'm going to drop down a 0x. And now it makes much more sense when I distribute this. I believe that was supposed to be a negative. Oh my God. I got a little bit ahead of myself just there. There we go. Right, because the way that we came up with this was we found out that in order to get the negative 2x squared, we have to multiply 2x by negative x. There we go. Now when I distribute, I bet that's going to sound really nice on the recording. Oh well. Moving right along. The negative x times negative 2 is going to be positive 2x. And now these are lined up, and I can change the sign and add. So I want to put the negative 2x here. And I drop down my 2. Okay. What do I need to multiply 2x by to get negative 2x? Well, that's going to be negative 1. I'll distribute the negative 1. I get negative 2x plus 2. When we add that, we get 0. And that is exactly what we wanted. So there we go. It turns out that this is equivalent to x squared minus x minus 1. Fantastic. Moving right along. Okay. We are not going to check our work by using the reverse tabular method. In fact, we're going to introduce something brand new here. We're going to introduce synthetic division for number 1. So let's talk about synthetic division. For synthetic division, if I could spell, that would be amazing. For synthetic division. Okay, this can only be done if my divisor must have a coefficient of 1 and, not or, but and, a degree equal to 1. So, for instance, We can't use synthetic division on number 2 because the coefficient is 7. It's got a coefficient. Can't do it. We can't do synthetic division on number 4 because it's got both things. It has a degree of 2, right? The denominator or the divisor has a degree of 2 and it has a coefficient of 2. But we can't do it on 3. And we can't do it on number 1. And we will. So here we go. I'm going to get very tight for room, but you are going to love this because it is so easy. I'm going to start off by making a little L here. All right? Right here, this number I'm going to put here is going to be the same as that number in my divisor, but I'm going to change the sign. So there's a positive 3 there. I will put negative 3. All right, the next part of the setup is I am going to represent the numerator, or the dividend, in terms of just the coefficients. So I have my coefficient of x squared is 1, and I'm going to put that there. My coefficient of x is 6, and then I have a coefficient of x to the 0 power, or my constant, and that's 9. I'm going to drop this 1 down. Okay? Now I'm going to multiply negative 3 times 1, and I'm going to place that directly under the 6. So I'll put a negative 3 directly under my 6. Now I'm going to add those straight down. 6 plus negative 3 is 3. Now I'll repeat the process. I'll multiply my negative 3, and I'm talking about this negative 3 that I'm multiplying. So I'm multiplying that negative 3 times 3, and that's giving me negative 9. And then I add my 9 and negative 9, and I get 0. This 0, this is my remainder. And we are multiplying we're dividing polynomials that don't have remainders at this point. So that's fantastic. We need that to happen. Okay. So what's my answer? What are all these numbers everywhere mean? This is my answer here. And it turns out that this is like 1x. And this is 3. So then my answer here is x plus 3. Okay? The way that I'm going to figure this out is, hey, my largest degree was 2. So since the degree of my dividend, or my numerator, was 2, then this degree has to be 1. Alright? We're going to do that again. We're going to do number 3. And then we'll return back to our long division. Okay? Let's do number 3 real quick. Okay. So I'm going to set it up. Again, I have my divisor is x minus 3, so I'm going to put a positive 3 here. I have an x cubed term. The coefficient of that is 1. Now, same as with both methods of division that we've learned so far, we have to put placeholders, right? So I am missing my 0x squared, my x, right? I'm missing my x squared term, so I'm putting a 0. I'm missing my x term, so I'm putting a 0. And then I have my x to the 0 term there. All right, I'll drop the 1 down. 3 times 1 is 3. 0 plus 3 is 3. This 3 times 3 is 9. I add those and I get 9. 3 times 9 is 27. Add those and I get 0. So how do I express this answer? It is going to be equal to, all right, first of all, my degree of my numerator is 3. So that means that this right here has to have a degree equal to 2. So that means that that's 1x squared plus 3x plus 9. And we're done. Really quick, really easy way to do division. But it only works if you have something like x minus 3, x plus 2, and stuff like that. Oops. All right, let's go back to long division. We'll get to practice both of these things a lot until you're really good at it. Here we go. Let's do a longer one with our long division. I'm going to go ahead and skip 2, just because I'm out of space, to be honest. All right, and we have plenty of practice. So let's do some polynomial long division. I've got 2x squared minus 3. Oh, what happened there? Looks like I'm missing a placeholder, right? And I need a little more room. So again, right? I'm missing my x term, so I'm going to give it a 0x. And we're going to divide 2x to the 4th plus 14 x cubed plus x squared minus 21x minus 6. All right, it's a nice big problem. We're going to get it done, though. Here we go. All right, I got to multiply 2x squared by x squared to get 2x to the 4th. I'm going to go ahead and distribute that x squared times 2x squared is going to be 2x to the 4th. Here I go distributing. We've got a 0x cubed, pretty much, right? When we distribute that x squared times the 0x, and x squared times negative 3 gives me negative 3x squared. Let's go ahead and subtract or change the signs and add. So I will wind up with a 14x cubed minus 2x squared and even though I have 2 terms here, I need to drop down this 21x because look, I have 3 terms in my divisor, so I should have 3 terms here after I have subtracted. So now I need to think, hey, what did I need to multiply 2x squared by to get that 14x cubed? Well, looks like 7x, right? Fantastic. And then I'm going to distribute the 7x again. So that will give me 14x cubed. And the 7x times the 0x is going to give me it's going to give me a 0x squared. And then 7x times negative 3 is negative 21x. I'll go ahead and change the signs and add. So I'm going to have a negative 2x squared here. And then that's a 0. So my x term has gone away, but I gotta still leave it there as a placeholder and drop down this negative 6. Okay, what would I multiply negative 2x squared by? Sorry, what would I multiply 2x squared by to get negative 2x squared? Well, that's just going to be negative 1, right? I distribute that negative 1 across my divisor, and I'll wind up with negative 2x squared plus 0x All right, so something's wrong. Because I should not have a remainder, right? If I combine these two things, I'm going to end up with a remainder of -9. And that doesn't work. So you were probably watching this thing, and you were saying, hey, Mr. Garman, did you know that x squared plus 3x squared is actually 4x squared? And I said, you know what, you are right about that. So this should be a positive 4x squared. All right, which means that this right here is going to change, and that's going to make our life great. This is 4x squared plus 0x minus 6. That's going to change this too, isn't it? Okay, so now we've got something different. We've got, what would we multiply 2x squared by to get 4x squared? That's going to be 2. And then when we distribute that, we get a bit of niceness. We get 4x squared there. Again, our 0x placeholder. And then 2 times -3 is -6. And we're in business. So now you know what it looks like when you make a mistake, and you know how to fix it, right? Boom. So there's our answer. So and this is equivalent to x squared plus 7x plus 2. All right, so in these cases, we know that we're not going to have any remainders. At some point in time later down the road, we will. But if you wind up doing the same thing, and you wind up getting something, and there is actually a remainder, go back through, try to find the little mistake that you made, and all will be well. Okay? All right, I'm going to skip 5 and 6 for the sake of time. And we are definitely doing 7 and 8. All right, so let's set this thing up again. 2x squared. I need a placeholder for my x value. Plus 1. That is going to go into 2x to the 7th. It's going to wind up being a little beastly, but you guys all the way have it in you. I'm going to need a little more space. All right. So I wind up with this 2x squared plus 0x plus 1. I'm going to have some placeholders in this thing. It's probably going to be pretty long. 2x squared, 2x to the 7th, plus 0x to the 6th, plus x to the 5th, plus 0x to the 4th, minus 4x cubed, plus 14x squared, minus 2x, plus 7. I mean, that looks like a good time right there. Come on. You know you're about to have some fun. Here we go. Let's do this. All right. So in order to get 2x to the 7th, by multiplying something times 2x squared, that something has got to be x to the 5th. All right, let's distribute it. So I wind up with 2x to the 7th plus 0x to the 6th plus x to the 5th. I'm going to change the signs and add. So the only thing that I have, well, I wind up with 0. And then I have a 0. And I drop that down. What in the world does that mean? That essentially means that I have a 0 here. And then I'm going to, right, and this is a 0x to the 6th. I'm just doing that so we get things to line up. so that when I distribute my 0, and this is essentially what, 0x to the 6. I'm just putting it there so that I don't get confused. All right, here we go. We want those to descend, not ascend, right? All right. So now when we distribute that, we just wind up with a bunch of zeros, right? 0x to the 6, 0x to the 5th, 0x to the 4th. The most important thing is that we're dropping this down, right? And let's look at this. I'm just putting all these placeholders in so that I don't get mixed up. I don't get disorganized. They're not 100% necessary. All right. So what do I need to multiply 0x to the 5th by? Oh, sorry. Yeah, to get or 2x squared by to get 0x to the 5th. Well, that's going to be just going to be a placeholder here, right? It's going to be 0x 0x to the 5th, or to the 3rd. Sorry, it's just a placeholder, right? 0x to the 3rd. Again, we multiply that thing out, right? And we're going to wind up with 0x to the 5th plus 0x to the 4th minus 0x to the 3rd. All right, now we get to change some signs and add, and I wind up with negative 4x cubed. And I'm going to drop down this 14x squared. Fantastic. What would I need to multiply? What I need to multiply 2x squared by to get negative 4x cubed? It looks like negative 2x. All right, so let's multiply this back out. Negative 2x times 2x squared is going to give me negative 4x cubed. And then I'll wind up with a 0x squared term. And also a negative 2x. Now we're missing this term, so we're going to have to drop down this 2x term. All right, I need a little more space. So let's go ahead and change the sign and add. All right, here we go. So I'll wind up with a 14x squared here. And a 0 here, but I'm also going to need to drop down my 7. Okay. All right, so what do I need to multiply 2x squared by to get 14x squared? That is going to be positive 7. And now when I multiply a positive 7, I'm going to get 14x squared. and a 7 here. Fantastic. When I change the signs and add, I get 0, which means that I am done. So this is equivalent to x to the 5th minus 2x plus 7. One more to go. That's it. One more. We're going to use synthetic division, so it's going to go really fast. Right? Remember, start with our L for synthetic division. In my denominator, I have x plus 2. So I'm going to use the opposite, or negative 2, over here. And I'm going to need a few placeholders for this, right? So I have 1x to the 6th, 0x to the 5th, 0x to the 4th, 0x to the 3rd, 0x squared, 0x, and negative 64 as our constant, or our x to the 0th power term. Let's make sure that's right. 1, 2, 3, 4, 5, 6, 7. Fantastic. I'm going to drop this down. Drop the 1 down. Negative 2 times 1 is negative 2. I'm going to add 0 plus negative 2 is negative 2. And then multiply. Negative 2 times negative 2 is 4. Add, and I get 4. Then negative 8, I add. Negative 8, I multiply. 16. Add, get positive 16. And now I will multiply and get negative 32. So that's going to be a negative 32. And then I will multiply again and get positive 64, right? And then when I add those, I get 0, which is awesome. I need a 0 remainder. So then what that says is that this is equivalent to, and remember, right? My highest degree of my numerator was x to the 6th, which means that this degree must be 5. So I'll start with x to the 5th minus 2x to the 4th plus 4x to the 3rd. Make sure that looks like a 3. Minus 8x squared plus 16 plus 16x minus 32. And there you have it. And that is all. Thanks for watching. We'll work on this a little more, and you get to choose the methods that you like tomorrow. Have a great evening.